All right, then finally we have gases in liquids. They behave differently than solids in liquids. So the most popular example of gases in liquids we can think about as like soda or beer or any sparkling water. All of these are said to be carbonated, right? Carbonated beverages, and that just means that we have carbon dioxide gas dissolved in them. So that's what that fizzing is. That fizzing is carbon dioxide gas leaving the solution. And so we have different solubility trends for gases in liquids. There's two main factors that are important. The first is the pressure. So this is how they first get that gas in the liquid. They pressurize it. So as we increase the pressure of that particular gas, we increase the solubility. And so that makes sense when you open a can of soda. You'll hear a fizzing, you'll see some gas, or you'll feel some gas leaving, and over time, the soda is going to go flat. And the reason that's going flat is because you're releasing the pressure, and so you're decreasing the solubility, and it starts going flat. The other factor that's important here is temperature. In general, as temperature increases, the solubility of a gas decreases. So for example, here's two sodas being poured. On the left one, it's a cold soda. And on the right one, it's a warm soda. And so you can see we have a lot more fizz on the warm soda. The fizz comes from the carbon dioxide gas leaving the solution. And it makes those little bubbles. And so as we can see, the warm soda, the carbon dioxide gas leaves much faster because it's much less soluble. The other very important, not necessarily application, but thought about this is water temperature. So fish like to live in water, and while they, breathe the water, if you could say, they're still extracting oxygen gas, O2 gas, from that water in order to be able to live. As the water gets hotter, there's less oxygen gas in that water, and if it gets hot enough, there's not enough oxygen gas, and then the fish die. So very important in terms of the environment.